Low Earth Orbit Satellites, or LEO for short. What are LEO satellites? Right, first let's define LEO. Low Earth orbit refers to the satellites that orbit between 180 and 2,000 kilometers above the Earth's surface. That's relatively close when you consider that geostationary satellites orbit at about 36,000 kilometers. Because they're so close, LEO satellites orbit the Earth much faster, completing a full orbit in around 90 to 120 minutes. This proximity offers some major advantages like reduced signal delay and higher transmission speeds. So what are they used for? LEO satellites are used for a variety of applications. Number 1. Global communications. Companies like SpaceX's Starlink and Amazon's Project Kuiper are using LEO satellites to create a new era of global internet coverage, even in remote areas. You can also include companies such as AST Space Mobile in that. Number 2. Earth observation. LEO satellites are critical for weather forecasting, disaster monitoring and climate research. Their low altitude allows them to capture high-resolution images of our planet. Number 3. Scientific research and exploration. From studying the atmosphere to enabling low-cost space experiments, LEO satellites play a big role in advancing science. So, how do they work? Now, let's get a bit technical. LEO satellites are often launched in constellations. Constellations are groups of satellites that work together to provide continuous coverage. Because they orbit so quickly, a single satellite can't stay over one area for long. That's where the constellation comes in, ensuring seamless service as one satellite passes overhead and another takes its place. Most LEO satellites are deployed via reusable rockets, drastically reducing costs compared to traditional space missions. Once in orbit, they rely on solar panels for power and ground stations to communicate with Earth. Next, let's look at benefits and challenges. Let's talk about the benefits and some of the challenges of LEO satellites. Firstly, pros. Lower latency compared to geostationary satellites. Affordable access to internet in underserved regions. High-resolution imaging and data collection. Now let's look at some cons. LEO satellites have shorter lifespans due to atmospheric drag, meaning they need to be replaced more frequently. Another con is the increasing number of satellites raises concerns about space debris. Next, let's look at the future of LEO satellites. The future of LEO satellites is bright. Beyond internet connectivity, they're paving the way for advancements in areas like autonomous vehicles, telemedicine, and real-time environmental monitoring. However, balancing innovation with sustainable practices in space will be key. So whether it's connecting the unconnected, improving global science, or enabling the next wave of technology, LEO satellites are changing the game. It's a reminder of how small satellites can, or rather, it's a reminder of how small satellites can have a big impact.